Enterprise technology is operating at a scale and velocity that historic corporate structures were never designed to handle. 14 distinct software engineering craft activities, from discovery to deployment, have now collapsed into a single, evidence-bound, AI-assisted product development pipeline. This chart illustrates the performance delta. The implementation of this pipeline has driven an 80% reduction in discovery to input effort and a 40% compression in total time to market. Code generation is no longer the binding constraint in enterprise software delivery. Solving the technical workflow broke the existing operating model. The primary friction point has migrated from machine execution directly to human management. This technical diagram outlines the legacy origin state: 5 layers of management separating the senior vice president from the engineering teams. Routing decisions through that dense hierarchy dilutes the AI pipeline's productivity gains, maintaining an architecture designed for a communication problem the machines already eliminated. The mandate for leadership is to identify a structural redesign that removes the outdated status routing overhead, while preserving institutional learning, craft capability, and the right to dissent. Applying military, corporate, and governmental lenses to this problem yielded 3 distinct, falsifiable organizational hypotheses. The recommended endpoint for Year 3 is the subsidiarity cell. It is a radical decentralization strategy built upon a 1,500-year-old operational framework. Extracting maximum value from modern algorithmic speed requires discarding legacy corporate pyramids in favor of a highly autonomous, cell-based architecture. In the 6th century, the Rule of Benedict established a highly precise operating constitution for distributed monastic communities. This model of monastic federalism enabled vast, coordinated networks of autonomous cells to operate cohesively across continents without relying on dense layers of middle management. By 1931, this architectural concept was formalized in Catholic doctrine as the principle of subsidiarity. The core tenet of subsidiarity is strict. It is an organizational failure to escalate a decision to a higher authority if that decision can be effectively resolved by a subordinate local unit. In the late 20th century, economist Elinor Ostrom validated this exact structure through her Nobel-winning research on polycentric governance, proving its efficacy for managing complex shared resources. Institutional resilience and scale are achieved by replacing top-down managerial control with small autonomous units bound together by a shared immutable operational doctrine. Legal scholar Yochai Benkler defined 3 strict structural conditions required for commons-based peer production to effectively replace traditional corporate hierarchies. This graphic tracks those requirements. Condition 1 requires a written, durable constitution. Condition 2 requires bounded cells, capped at Dunbar's number of 15 individuals. Condition 3 is extreme modularity of work. For decades, this was the binding constraint preventing cell-based models. The maturation of the generative AI pipeline has finally made complex software development modular enough to satisfy Benkler's 3rd condition. The arrival of the AI pipeline provides the foundation for a decentralized human operating model that was previously unreachable in enterprise IT. This animation shows the collapse of the traditional management pyramid down into a flat network containing just 3 hierarchical layers. The traditional engineering team is replaced by a new atomic operational unit known as the parish. Each parish consists of a tight, agile trio: product, engineering, and design, backed by specialized AI agents. These AI agents function as the execution layer, rapidly processing modular tasks in perfect coordination beneath the human strategists. Above the parishes sit 8 diocesan VPs. They function exclusively as policy nodes and doctrine enforcers, rather than traditional taskmasters or approvers. To maintain technical excellence across the network, the model introduces itinerant craft orders for architects and designers. These orders exist outside the standard management chain. Senior experts rotate laterally between parishes to solve capability gaps, mentor local teams, and enforce architectural standards. By stripping away middle management, the organization becomes a fluid network of empowered, AI-backed cells aligned by shared rules and expertise. The subsidiarity cell architecture carries one critical vulnerability: the mimetic transition problem. To operate this model successfully, employees must make meaning at a significantly higher cognitive level than a traditional hierarchy demands. When advanced self-managed systems are deployed without addressing this psychological gap, they trigger a bimodal split. Operators interpret the new design language through their old value system, degrading the structure into a chaotic version of the legacy org chart. Macroeconomic data confirms this risk. 63% of employers currently cite the workforce skills gap as the binding constraint on organizational transformation. This diagram maps the necessary psychological shift. The workforce must move from a legacy, permission-seeking mindset into a self-transforming capacity capable of executing mission orders. The operational solution to this vulnerability is an institutionalized apprenticeship academy. It actively upskills internal talent as a fixed, non-negotiable cost. Imposing an advanced, decentralized structural design onto a workforce operating with legacy cognitive frameworks guarantees failure. Deliberate human development is the foundational infrastructure of the AI era. This timeline illustrates the transition. The subsidiarity cell marks the end of a disciplined 3-year roadmap, providing a controlled path toward total cellular autonomy. Year 1 introduces Centurion, eliminating the director layer and elevating architects to a general staff. Year 2 establishes the viable network, introducing cybernetic operations rooms with real-time data walls to manage coordination without middle management committees. Year 3 executes the transition to the subsidiarity cell, but only if the apprenticeship academy proves successful at upskilling the workforce over 2 years. Moving an enterprise to extreme decentralization requires strict conservative staging to protect existing capital, retain operational stability, and mitigate the shock of the transition. This governance text outlines the strict falsifiability mechanics built directly into the roadmap, culminating in a definitive 24-month evaluation gate. The decision to proceed rests on objective KPIs, the throughput of the apprenticeship academy, measurable fidelity to the operating doctrine, and the stability of intercell coupling. If any of these metrics fail the evaluation, the organization executes a mandatory reversion protocol, rolling back safely to the Year 2 viable network baseline. Modern IT leadership faces a stark choice. The software pipeline is heavily automated. Surplus human capacity must be directed toward a new structural purpose. Automating code production has become the baseline. The differentiator now lies in dismantling obsolete hierarchies and empowering developmentally ready humans to run autonomous, high-velocity cells.